We are talking about geometric progressions, GP for short, and sometimes they are called exponential sequence because they increase exponentially. That's divisions and multiplications. Okay, so this is the general formula for a GP. That the nth term, that is any number of term you want to find out, is equal to the first term a multiplied by the common ratio raised to power that number of term minus 1. Now we'll be using an example to understand what this formula is all about and how to use it. Example, from the following GPs we are to find the fifth term, the 47th term, and the nth terms. So this is the first GP we'll be working on, and this is the second one we shall be working on. So looking at this first GP, we can see that the first term we are seeing is equal to 2. So as a way of solution to the A question, the first question, we have solution, we have A, that the first term is equal to 2, like we can see that. Now common ratio R is usually equal to any of the terms you pick out divided by the one coming before it. So I'll pick out the second term divided by the term coming before it, that is the first term, which is equal to 10 over 2 is equal to 5. So the common ratio is equal to 5. And at first we are tasked to find the fifth term. That is the position of the term. That is what n in this general formula represents. So n is equal to 5 because we are looking for the fifth term, the position 5, when we arrange the sequence. So here we already have 1, 2, 3, 4. So we are looking for the fifth one, the very next one. Okay, so we now write out the formula so we can substitute directly. We have that okay, the general formula, the nth term is equal to a multiplied by r raised to power n minus 1. So the term we are looking for is term number 5, right? Is equal to the first term multiplied by r is 5 raised to power 5 minus 1. Okay, so we have it as 2 into 5 raised to power 4. Okay, so now we have 2 times, this is 5 times 5, 25 times 5, 125 times another 5, 6, 2, 5, which is equal to 1250. So the fifth term of this GP is equal to 1250. Okay, so we go over to the second thing we are tasked to find out from this GP. We have, this was the first thing. The second thing is the 47th term. So n is equal to 47. So the 47th term is what we are looking for. Okay, we substitute into the general formula that says that term number 47 is equal to the first term, which is 2 into 5 raised to power 47 minus 1. So this is equal to 2 into 5 raised to power 46. So this is a very, very large number. When you get this from a calculator, you're going to see a very large number. So if they are really large numbers, you can leave them in their indices, in their index form. Okay, so the third thing we are to find out from that GP is the nth term. So this is just like saying the general formula for that particular GP. So for the nth term, we have that A for this particular GP is 2, and then R is 5, right? N minus 1. So here we don't have any other thing to do with this, like we could leave it this way. There is no other breakdown. The very next example, that second GP given in this question, will help us to understand what I mean by there is no further breakdown. So I had to bring down the second GP given to us, geometric progression. So we can see this is reducing over time. So let's get our parameters from this one. We have that the first term is 81, like we can see. Then the common ratio is equal to, I could decide to pick the second term divided by the first term. That's a large number. So let me just pick this, divide by this one coming before it, because you can actually pick any of them and divide by the one coming before it. So 3 divided by 9. So 3 into itself is 1, 3 into 9 is 3. So the common ratio is 1 over 3. And the first thing we were asked to find is the fifth term. So we are looking for the fifth term. So for the fifth term, n is equal to 5. So that's the position of the term we are interested in. Okay, so we write the formula. We have that the formula is equal to a r n minus 1. That's the general formula. So we substitute into it. The fifth term is equal to a, which is 81, and then r, which is 1 over 3 raised to power n, which is 5 minus 1. Okay, so we have that 81 into 1 over 3 raised to power 4. So this gives us 81 into 1 over 81, because that's what 3 raised to power 4 is. 1 raised to power 4 is 1, and 3 raised to power 4 is 81. That's 3 times 3, 9 times 3, 27 times 3, 81. So we can see that we can divide into this to have that the fifth term is equal to 1. As surprising as that is, but that is what it is. Okay, so we have to look for term number 47. That's the next thing we are to look for. Term number 47. So term number 47 is equal to the first term, which is 81 into 1 over 3, that's r, raised to power 47 minus 1. So this gives us 81 into 1 over 3 raised to power 46, right? Okay, so now we can see 81 and 3. We can further simplify this because 81 can be brought to base 3, so we can work with base 3. So let's bring 81 into base 3. So from the previous example, we have that 3 raised to power 4 is equal to 81. So we have that 81 is equal to 3 raised to power 4. 1/3 to 46. Now we can further get this to same base. That's saying 3 raised to power 4 multiplied by 3 raised to power negative 46. That is to eliminate this fraction. To bring it up, the inverse, we have to introduce negative to the index. Okay, so this is actually multiplication. So we are now using the knowledge of indices that we already know to simplify this. So we have 4 minus 46 is minus 42. So we have finally that the 47th term for this GP is 3 raised to power negative 42. That's the simplification we can go over, because this is a large number, so we can't just leave it this way. We can tidy up it up to having one term. Okay, so that is it for this. So the general terms, the general term for the general formula, that is whenever you ask for the nth term of a GP, they are actually asking you for the general formula of that particular GP. So this is nth term is equal to the first term of this GP is 81. The common ratio is 1 over 3 and raised to power n minus 1. So let us break all this down to base 3, because we can actually leave our answer in base 3 just like we have here previously. So we have 3 raised to power 4, right? Into 3 raised to power negative n minus 1. So we can actually have it this way, right? Okay, let's simplify. We have 3 raised to power 4 into 3 raised to power minus n is, that's minus times n is minus n, minus times minus 1 is plus 1. So let's start with the positive 1 minus n. So this is what we have finally. Now, let's collect them together. We have 3 raised to power 4. It's multiplication, right? So 4 into 4 times 1 minus n as a whole. So we have it as 3 raised to power 4. Okay, it is times 3l, so that's plus, sorry. This is plus, not times. 4 plus 1, which is 5, and then minus n. So this is what we have finally, that the nth term of this GP is equal to 3 raised to power 5 minus n, because that's just it. To add it up, since it's multiplying, 4 plus 1, that's 5, minus n is not a like term, so it keeps on being what it is. So any of these GP we pick up and then do this to it. Like when we looked for the fifth term, we have to say 3 raised to power 5 minus n. We have the fifth term, that's n is equal to 5. So 5 minus 5 is equal to 0. That was why that fifth term, because anything raised to power 0 is 1. That was why that fifth term is equal to 1. So we can see that this general formula can solve any of the terms in this particular GP. Now we have this very next example. The first, second, and last terms of a GP are 3, 6, and 768 respectively. Calculate the number of terms in the GP. Now, first of all, we can't panic. We have to just go over writing down our parameters so that we can understand what we should do. So the first term A is equal to 3, the second term T number 2 is equal to 6, and the last term T number N is equal to 768 according to the question. And what are we looking for? Calculate the number of terms. So how many terms are there? So this last term, 768, what number of term is it? Like what position is it? That is what N represents, the position of that term. Okay, so like we said that we have A. So common ratio, that is what we need, because the general formula for that nth term, the nth term of a GP is equal to ARN minus 1. So we have A, we are looking for N. So from this formula, and we already have the nth term, right? 768. So from this formula, the missing term, because we are looking for this, so the missing term is R. And we know that when to find the common ratio, R is equal to a term divided by the previous one. So in this question, we've been given the first term and the second term. So the second term, 6, divided by the previous one, which is the first term. So 6 over 3 is equal to 2. So the common ratio is 2. Now let's substitute into this equation. We have that the nth term is 768 is equal to the first term, which is 3, into the common ratio, which is 2, and then we don't know the number of terms, so it keeps on being this. Okay, so we progress from here. What we now do is we divide both sides by 3, because we want to, in any equation you want to solve, what you want to do is to isolate the unknown term. So we divide both sides by 3, so it goes away, we just left with this bracket. So when we divide both sides by 3, we are going to have, okay, 3 into 7 is 2, remainder 1, 3 into 16 is 5, remainder 1, 3 into 18 is 6. So 256 is equal to 2 raised to power n minus 1. Now, the unknown we are looking for is at the index. Okay, so what do we do at this point? We have to get these two numbers to same base. This is already in base 2, so we get this into base 2. And how do we do that? Let me work with another color of pen. We have that. I'm going to do that on this side. 256. We want to get it to base 2. So this is how to get any number to a particular base. You keep on dividing by that number. 2 into 2 is 1, 2, 8. So we have 2 into 12, that's 6 and 4. 2 into 64, that is 3 and 2. 2 into this is 1 and 6. 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. 2 into itself is 1. So how many 2's do we have here? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So we have that 256 is actually equal to 2 raised to power 8. So we have that 2 raised to power 8 is equal to 2 raised to power n minus 1. Now we've equated the bases. we've gotten them to same base. Now what we do is equate the powers, like just cancelling out the bases. So equating powers, 8 is equal to n minus 1. Okay, minus 1 crosses over to become plus. That means 9 is equal to n, or we can say n is actually equal to 9. So we have found the number of terms in this GP. You can see the thought process. Okay, let's solve another word problem on GP. The system of a GP is 2000. Find its first term if its common ratio is 10. So the normal thing we do is we write out the parameters that we are given. The sixth term. So T number 6 is 2000. Find its first term. So we are looking for A, the first term, if its common ratio R is 10. So remember, T number 6, that means the position n is equal to 6. So we've written out all the parameters we are given. The system is 2000, we are looking for the first term, and the common ratio is 10. Since it's the system, so the n, the position of the term is 6. Okay, let's of course write out the general formula of a GP. So we have that T, the nth term is equal to A R n minus 1. We substitute into this. So the sixth term, T number 6 is equal to A. We don't know A. That is what we're looking for. So it keeps on being A into R. Oh, R is 10. So we substitute that. 10 raised to power n is 6 minus. And remember, all this is equal to 2000 according to this. Okay, so we have A into 10 raised to power 5 is equal to 2000. Now we've been working with indexes, that's numbers indexes. So it's easier for us to divide this using indexes. So let's get this 2000 in index form. So we have A into 10 raised to power 5 is equal to 2 times 10 raised to power 3. That is 2 times 1000. 1000 is 10 raised to power 3. That is 3 zeros. So what do we do now? We want to isolate the unknown term, right? So we divide both sides by 10 raised to power 5. And we know that when we have indices, 2 times 10 raised to power, this is 3, right? Divided by 10 raised to power 5. So when we do divisions, when we bring it up, it's going to be minus 5, right? So we have is equal to 2 times 10 raised to power 3 minus 5 is minus 2. So we could have that the first term is equal to 2 times 10 raised to power minus 2. Or when we give that in numbers, we have that is equal to 0.02, because that's just it, 2 zeros before the significant term. So we have found the first term of this GP. Now let's solve one more. Find the common ratio of the exponential sequence, that's a GP of log x, log x squared, log x raised to power 4, and so on. Okay, so this looks a little bit strange, but what do we do? Let's write out our first term. Okay, let's rewrite this. Don't just get scared. Let's rewrite this. We have log x. Remember, log of a term to the raised, so we can write this as 2 log x. That's another form of writing this. So this becomes 4 log x, and so on. So it's now easier in the eyes, right? Okay. So we have that the first term A is equal to log x. We have that the common ratio is, we pick out the second term, which is 2 log x, divided by the first term, which is log x. We can see that the log x is cancelling out log x, therefore the common ratio is 2. It's now getting easier in the eyes, right? Okay. So we've been asked to find, oh, we were told to find the common ratio. Oh, that's all. So we can, even from here, we can find the next term. From what I can see, the next term is going to be log x to the power of 6. So that's just it.